Today we're going to the Duluth Aerial Lift Bridge to discuss a really important topic in computer science, algorithms. Okay, in this video we're going to tackle the problem of program design. This is the place we start. Whenever we want to design a program, we begin by thinking about what's our strategy going to be. And here's a problem that people all have in this class. Everybody wants to know how to get an A, or at least how to get a passing grade. But let's take the A. What's your solution strategy going to be for this? Think about it. If it's a large class, I might call on you. But what's your solution strategy going to be? Usually people say things like this to me when I ask the question. They say, well, I want to do well on the exams, and that means I gotta watch the videos, and I'm gonna have to read the book, and I'm gonna have to take quizzes, and complete the projects and view all the lectures. And all of that's true. That is a solution strategy. If you do all these things, you have a pretty good shot at getting an A. Certainly you have a good shot at passing the class. But this solution strategy is kind of the shotgun approach. It's like saying, well, here's a whole bunch of things I know I've got to do to solve the problem. They're not arranged in any type of orderly fashion. And what we're going to find out today is that order is essential. If I take the suggestions for how to get an A and I put them in order like we had, it doesn't make any sense. First thing I'm going to do is take all the exams. And after I've done that, then I'm going to watch the videos. And after I've done that, I'm going to read the book. And after I've done that, I'm going to take the quizzes. And after I've done that, I'll complete the projects. And the last thing I'm going to do is look at the lectures. I mean, that doesn't work. The pieces are here, but they're not in any kind of an order. And I'm not sure they really, you could get them in much of a better order than what we've got in Canvas, which is kind of complicated. So instead, we have another approach. That's not an algorithm. To solve our problem, we need to come up with an algorithm. An algorithm is an ordered list of steps for solving a problem. If you have a solution strategy that progresses from one task to the next, to the next, to the next, you finish one task, then move on to the next one, finish that, move on to the next. Even really complicated problems can be addressed in that kind of a systematic, orderly fashion and solved. So for this exercise, what I'd like you to do is pretend you don't have a cell phone or a computer, other than whatever it is you're viewing this lecture on. Okay? But don't use your electronic devices to solve this problem I'm going to give you next. And usually this would be a group problem, but if you're on your own, it's just going to be you. You'll have to kind of use your own resources. And I'm going to ask you to come up with an algorithm. We are going to use algorithms to solve every problem in this course. And in this exercise, you're going to have to construct an algorithm for a very common, simple problem. And don't take longer than 10 minutes. If you get done before that, great. But don't agonize over this one for a long time. It's going to involve this landmark, the Duluth Aerial Lift Bridge. If you know where this is, you're probably in great shape. If you don't know where this is and have no idea then don't worry about it. You may not be able to come up with any kind of a decent solution to our problem, because here's what the problem is. Imagine you're at UMD. You're standing outside of the bus stop in front of the UMD food court when you're approached by a strange device. Looking like a Segway on steroids, a robot wheels up to you and demands, "Hey, how do I get to the lift bridge?" That's the lift bridge, right? Okay. You solve the problem by explaining in detail how to get there. But here's the deal. Your solution has to be perfect. If the robot can't get to the lift bridge, it's going to be frustrated, and it's going to come back to campus and hunting for you. the thing scanned your DNA. It knows exactly how to track that and find you. So you don't want that. You don't want that. You want to make sure that you give it the right instructions about how to get down there. All right. Now, as you think about how to solve the problem, I've had the most creative suggestions for solving this ever. I've had people say, "Oh yeah, just call an Uber or Lyft, and or have him grab onto a bus that goes down there." But no, this robot has to get there under its own power. So you can't take an Uber or Lyft or anything else like that. Very creative, but no. Also, this robot doesn't have a cell phone or any way to connect to Google Maps, and nobody around this robot can use Google Maps to give it directions. So that's the business about putting your electronic devices away. You're going to have to figure out how to explain to the robot how to get down there without relying on any other resources. You can assume the robot knows how and follows traffic rules and all that kind of stuff. It knows what a stop sign is, and it can handle all that. You just have to give it directions. Okay? So pause this video and write down your directions. How would you get from UMD down to the aerial lift bridge? Be as detailed as possible and put things in order. We want to come up with an algorithm, an ordered list of steps to solve this problem to give to that robot. And when you're finished, come on back. Again, don't take longer than 10 minutes. And if you have no idea how to solve this one, fine. Then just think about it for a minute or so and then come back. But either way, when you've solved this and you're ready to move on, then come back. But hit pause now, and then I'll wait for you here. Okay? So now you're back. If you've finished, we can move on. Here's a map of Duluth with the University of Minnesota Duluth at the top and the aerial lift bridge at the bottom. And you can see a whole bunch of streets marked here. Now, if you're a Duluth resident and you know all about this, maybe you could rattle off every single street the robot has to take. Most people couldn't do that. I know this. If I'm in a strange town and I can't find something, and I ask somebody, how do I get down to wherever it is? If the person rattles off a list of streets and turn left and turn right and whatever, I know two things. I know, number one, that was the right person to ask. They know how to get me down there. And I also know, number two, I'm never going to remember all this. It's just, I'm never going to remember it. So I'll probably have to ask somebody else in a few blocks. Now, there are other ways to give instructions. The person could use landmarks. They could say, well, you go out to that white building and then take a left. And if they don't know the street names, that might help me. Or the person could really just assume that they don't have to give any street names at all, and they would just say, well, go down the hill. Go down the hill. The lift bridge is about 3 miles that way, and once you get down to the lake, then look down there and you'll see it, and just head that way. And that might work too. That's actually a much better solution strategy, I think, for most of us. We could figure that out instead of having to memorize every little street name. But the robot is not going to handle that. Machines have to have instructions that are very detailed, or they're going to get lost. So how would we handle this? Now we can revert to Google Maps, and there we go. This is the current version. On the day that I did this, you can see that there's some road construction down near the bottom, near the lift bridge. So it had to route us around a kind of an odd way. But this is a series of routes that we could take. And the shortest one, 12 minutes, is the blue one. And you can see it's street by street by street by street, all the way down there to get to the aerial lift bridge. But it's not the only solution. There are a couple others that are there. They're not as fast as that blue route, but they will solve the problem. And this is one of the things that will come up during the semester. We're going to try, when we come up with our solutions to programming problems, to find not just the right solution, one that solves a problem, but the most efficient solution. So I have had situations where people will write code on an exam to solve a problem and they lose points. And they'll say to me, but wait a minute, I did it right. This solves the problem you asked me to solve. And I will say, yes, but it didn't do it efficiently. Okay? This is a kind of thing that takes us way off in some direction, and eventually we get where we're going, but there's a much more efficient way to do it. And so as we look at this map, we can see there's a variety of routes, but there's only one that's really efficient, and that's the one we want to shoot for. Now, what are those directions? Well, fortunately, Google Maps will tell us all the directions, blow by blow, every little street. From where you are now, go out to College Street and take a left, and then follow that down until you get to Woodland and take a right, and then go down and take a left on 21st, and then get on to I-35 at the ramp, and take I-35 toward 5th Avenue West, and so on. It can give us a detailed list of instructions. That's kind of a nice thing about Google Maps. That is an algorithm. An algorithm, an ordered list of steps. Go out to College Street and turn left. Once you've done that, then go to Woodland and turn right. Once you've done that, then go to 21st and turn left. So we have to accomplish the earlier steps in order to solve the steps that we're currently on. And as we solve these tasks one after the next, eventually we solve the problem. So that's where we're going to head. And in the next video, you'll see 2 examples of problem solving that starts with algorithms, ordered lists of steps, and turns them into computer programs. And that's a fundamental skill, something we're absolutely going to have in this class. But you can see that an algorithm itself is nothing more than an English solution to a problem. We're just describing how to solve the problem, but we're doing it in an orderly way, with each task in as much detail as we can, laid out one after the next, and that's where we're going to head. So thank you for watching, and now take a look at the next video where we use the concept of an algorithm to actually write some C++ programs. Thanks for watching.